Hey, good morning, afternoon, or evening. I hope you're doing well. I'm doing great. Thanks for asking. If you haven't got a piece of paper out, find one. 4.2, right triangle trig. Hit pause if you got to find that piece of paper and go get it. Take it ready for some notes, for some cool stuff for an application of the unit circle trig. All right, so when I take a look at my circle here, we just took a circle and we put a triangle with it, and the center of our circle is going to be at the center of my the center of my circle will be at the vertex of that triangle. We're going to call this triangle ABC, the big one. We're going to call ABC. I'm going to make it a right triangle. Right? A couple things about our triangle ABC. Side opposite angle A will be side A. Side opposite angle B will be side B. Side opposite angle C will be side C. Okay. The other thing I'm going to take a look at is I'm going to take a look at a smaller triangle. I'm going to look at this point right here, and I'm going to look at this triangle right in here. I'm going to call this red one a unit circle triangle. And both of the the big triangle, triangle ABC, and my unit circle triangle, my red one, will have an angle of theta. Okay? And if I think about this, I'm going to go after this point right here, that's on my unit circle, that's on the hypotenuse of my big triangle, that's the vertex of the acute angle of my smaller triangle. I'm going to call that x comma y because I really don't know what it is. But besides x comma y the other day, we looked at this, we also can call it, hey, what's x? It's the same as the cosine of t, which is the same as the cosine of that angle. So cosine theta, and y is the same as sine theta. So we can name this point right here two different ways. We can name it either x comma y, or we can name it cosine theta, sine theta. And that's going to be important. So when I look at my two triangles, I'm looking at my triangle ABC, I'm looking at the big triangle, and I'm looking at that smaller right triangle. I notice that those two triangles are similar. I think about my time in geometry, and I can say triangle ABC is similar to the unit circle triangle. So now we got to think about similar triangles. Let's think about what's going on with similar triangles. Oh yeah, from geometry I remember similar triangles and corresponding angles are congruent. I agree 100% with you. That's not what we're going to use here. We are going to use the fact that the corresponding sides, 3 dots in a triangle, therefore, corresponding sides are in proportion. Maybe I can spell. Okay, maybe. So they're proportional. So now we got to figure out what those proportions are. Well, for me, it gets a little bit confusing with one triangle sitting on top of the other triangle. So what I'm going to do is I'm going to draw those two triangles separately. I'm just going to pull those two triangles off of my unit circle, off my circle, so I can see what's happening. First, I'm going to do this smaller unit circle triangle. I'm going to do this triangle where I have a theta here, when I have that point xy, and if I think about it, there's my x-coordinate, which we're calling the cosine of theta. There's my y-coordinate, which we're calling the sine of theta. And that's a right triangle, and the hypotenuse of that right triangle is 1, because that's the radius of my circle. So we have a circle with radius 1, and I forgot to put that up there. We'll put that up there, radius of 1. Now my bigger triangle, triangle ABC, is all bigger. There's theta, that's that same angle. And then we have A, B, C. It also is a right triangle. Opposite angle A is side A, opposite angle B is side C, opposite angle B is side B. Opposite angle C is side C. Okay. All right. And what do we know about these two? These two both are similar. So if you guys remember that similar symbol, I'm trying to figure out where I can fit it. It's that little squiggly line. That's from geometry. That just means those two sides are similar. So using our thoughts of geometry, we can write several proportions using these two triangles. We're going to match our sides that correspond to each other. All right. So what we're going to do is we're going to first take a look at this red triangle, and I'm going to talk about the sine of theta over 1. So I'm looking at the two sides. I'm looking at, I'm going to change my pens real quick. I'm looking at the sine of theta, that side compared to that 1. Well, to write my proportion, I look at the bigger triangle, and what deals with the bigger triangle? Oh, the sine theta, it corresponds to, sine theta corresponds to A, so I'm going to write A over, and my 1, it corresponds to that C. All right, so that's going to be over C. Now, when I think about that, oh, that's, when I go after that, if I want to, or not want to, but I'm going to, hey, compared to theta, now I'm looking at theta right now, compared to theta, that side is, I'm going to call the opposite side. All right, now it's tough to fit in. And the side of C, okay, I'm going to call that the hypotenuse. So now instead of A over C, so when I look at this A over C down here, oh, that's the opposite side over the hypotenuse. Now if I go back and look at the beginning, I'm looking at the sine of theta over 1. That's just the sine of theta. It's equal to the opposite over the hypotenuse. Oh wait, I've heard that before from geometry. Oh yeah. Well, that's pretty cool. So what you're saying is that sine theta equals opposite over hypotenuse just comes from similar triangles. That's exactly what I'm saying. It's just an application of unit circles. Hey, I wonder if that works for the cosine. Let's take a look. So now I'm going to look at the cosine over 1. So I'm going to do cosine theta over 1. That equals, well, what corresponds to cosine over in the bigger triangle? That would be B. What corresponds to 1 over C? Oh, B, instead of, since I'm looking from my angle, you guys remember this, if I'm looking from that angle theta, so we're still here at theta, and the B is going to be called the adjacent side. So that tells me B is adjacent over the hypotenuse. So if I go back to the original, oh, cosine over 1, so now I'm looking here, what's cosine over 1? Oh, that's cosine of theta equals adjacent over hypotenuse. Oh, I've heard that before too. Adjacent over hypotenuse is equal to cosine. And now let's do the tangent. Well, what do we know about tangent? Well, tangent is equal to sine over cosine. So tangent theta is equal to the sine of theta over the cosine of theta. If I go back up and look at my triangles, what's corresponding to cosine? That would be B. What's corresponding to sine? That would be A. So this is going to be equal to B over A. And then what's B? B is opposite, I'm sorry, did I do that wrong? Cosine is, I'm sorry, what's corresponding to sine is going to be A. Made a mistake, let's erase. Good thing I have an eraser. Let's hit the rewind button, and let's make sure we have this right. When I look at sine, cosine, tangent is sine over cosine, so it's sine over cosine, so what corresponds to sine? That's A over B. Let's make sure we get that correct. So sine is A, cosine is B. A, when I go back to my big triangle, A represents the opposite side, So A is the opposite side. Over adjacent for B. So then my tangent of theta is equal to opposite over adjacent. Memorize those three. Oh, that's pretty cool. Hey, that sounds like something I've done before. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Oh, that's SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that's SOHCAHTOA. That thing you learned in geometry, it just comes from looking at similar triangles from the unit circle. So that's the big deal there, is that we can get these proportions, we can look at those proportions, and we can get them using these similar triangles. Let's do an example now. How are we going to ask you to use this? Fantastic. I'm going to give you a picture. I'm going to give you a couple bits of information. In this case, I gave you a side of 12, a side of 5. It's a right triangle. That's SOHCAHTOA. If I jump back real quick, this SOHCAHTOA, remember, this only works in right triangles. So this is right triangle trig and right triangle trig only. Notice the heading we have is that we're only talking about right triangle trig. Okay, so if I have a right triangle, I can do SOHCAHTOA. If I don't have a right triangle, I cannot use the information that we just discovered, or relearned, I guess I should say. All right, so the first thing I'm going to do is I have to find that h. That's probably the first thing I'm going to go after. So you guys hit pause. After I say go, hit find h by using Pythagorean theorem. Hit pause. All right, welcome back. Hopefully you discovered that h was equal to 13 by using Pythagorean theorem, because you said h squared is equal to 5 squared plus 12 squared. And you did all your math and you got h to be 13. And I'm going to assume you guys can use Pythagorean theorem. If not, let me know. We can work through it. All right, so now it says find the 6 trig values of theta. All right, so I want to find sine theta, cosine theta, tangent theta. Notice I talk about finding my angle, and I don't need to know my angle. Okay, so the first thing I do is I look from theta. Oh, well, from theta, my 13 is the hypotenuse. From theta, 5 is opposite, and 12 is adjacent. So now I just remember what's going on. Oh, if I think about SOHCAHTOA, let's do red. If I think about sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I just pull the stuff off. Sine is opposite over hypotenuse. Opposite is 5. Hypotenuse is 13. I'm done with it. I go on to the next one. Cosine of theta. Adjacent. Adjacent is 12. Hypotenuse is 13. I'm done with it. Tangent. Opposite over adjacent. Tangent is 5. Adjacent is 12. I'm done with it. Now I got to get my other six trig functions. What I do is I don't look at my triangle anymore. I just know my relationship. Oh, when I think about sine, its reciprocal function is the cosecant. So I'm going to say the cosecant function of theta is the reciprocal of the sine. So I just flip over 5/13 and get 13 over 5. The reciprocal of cosine, the reciprocal function of cosine is secant of theta. So it's 13/12, so I just flip over the 12/13. And the reciprocal of tangent is cotangent theta. Just flip it over, it's 12/5. Okay. From that, we will continue in class, and hope you understood. If not, hit rewind and kind of go through it. I know I went fast at the end. Good luck. If you have questions, let me know.